This is the video for net ionic equations. What we're going to do is we're going to take a double replacement reaction and try to find its net ionic equation, because what happens when you have ionic compounds and you dissolve them in water, they break down into their ions. So typically when you have water, unless it's distilled, it will have ions in it. So for example here, you have two fishermen who are using a net to try to catch fish. But if you look close enough into the water, you can actually see that I've written some ions in there. And that's pretty much what's happening in the water. is you have a bunch of other chemicals in there along with the H2O. So we're going to go through some steps to finding the ionic equation and the net ionic equation. So the first thing is you're going to balance the chemical equation. So when you balance the chemical equation, you should get 2 here, and that's it. Okay? If you're unsure of that process, you need to go back and look at the balance the equation video or stay after school for extra help. Okay? Next step. Write this as a complete ionic equation by writing all compounds that are aqueous as ions. Do not separate the solids. So pretty much what you're going to do is take all of these things that are aqueous and split them into their ions just as they do in the water that they're in. So, for example, we're going to take CdNO32 and break it into its ions. So literally we are going to split them. Okay, so cadmium is Cd, and you need to have 3 things written. You need the symbol, the element symbol, the charge, and the state that it's in. So cadmium is one of those 6 exceptions where we know the charge to it. So cadmium has a charge of 2+, and the whole compound is aqueous, so therefore cadmium is aqueous. Okay, plus, okay, how many nitrates do we have? 2, so all these subscripts are going to become coefficients. So you're going to write it as 2NO3. NO3 has a charge of 1-, and it is aqueous. So for every ion that you have, you tell me how many, symbol, charge, and state. So we have 1 cadmium, 2+ charge, aqueous. 2 nitrates, NO3, 1 negative, aqueous. And you just keep doing that for all of the aqueous compounds in the reaction. So our next one is Na2S. So we're going to do the same thing. We are simply going to split it up. So how many NAs do you have? 2, so that's going to become 2 Na. Sodium has a 1+ charge, and it is aqueous. Plus, do the same thing for sulfur. How many S's do we have? 1, so S. Sulfur has a charge of 2-, and it is aqueous. Okay, now we come to the arrow, so we write our arrow. Technically, you can keep on going if you have the space. I don't have enough space, so I'm going to drop down here. And then we get to CDSS. This is where you need to star this, highlight this, do whatever you have to do to remember that the solids, they are solids in the water, so they are not splitting up. They're sitting at the bottom of that aqueous solution, forming a powder of some sort. So that means we are not going to touch the solids at all. They stay written exactly like they are. So CDSS. Don't split it up. Plus, now we get to another aqueous solution, so we're going to split it up. Okay, so how many sodiums do we have? 2. Remember, this 2 out in front is distributed to everything that's in it. So we have 2 Na with a charge of 1+, and it's aqueous. Plus, again, the 2 is distributed, so we have 2 NO3s that has a charge of 1-, and it is aqueous. You have written the complete ionic equation. This is showing you all the ions that are involved in the reaction, and it's showing you that solid that is being formed. This solid that's being formed is the driving force behind this reaction. With no solid, this reaction would not occur. You would just have a bunch of ions floating in the water and nothing would happen. Okay? So the solid is your driving force. So what needs to happen is you're going to take that driving force and you're going to write what's called the net ionic equation. So we talked about this word net before. Net is the overall reaction. Okay, to get the net, you're going to cancel out all terms that appear on both sides. Now when you cancel out terms that appear on both sides, they need to look exactly the same. If not, then most likely you did something wrong. Okay, so for example, cadmium 2 plus is here, but do you see cadmium 2 plus on the right side of the arrow? No, they do not look exactly alike. 2NO3, 1 negative, 2NO3, 1 negative. So that goes away. Okay, another one, 2Na1 plus, 2Na1 plus. S2 negative. Do you see it on the right side of the arrow? No. The ions that you crossed out are called the spectator ions because they are not actually a part of the reaction. They are simply watching as the other ions form the solid. So, your final answer, your net ionic equation, is simply going to be CD2 plus AQ plus S2 negative AQ produces CDSS. Now, a way to check yourself is that your product should always just be the solid that's being produced. And then, of course, the ions on the left side should be what makes up that solid. Okay? Now, on your test, you will have one of these, and it will be worth 10 points. Each part is going to be part of the answer. So you have to be able to give me the complete ionic, and you have to be able to give me the net ionic. So let's try another one. Now this one has a slight twist to it because we have to go back to something that we've done before. So we have Cu2SO4AQ, barium chloride AQ produces copper chloride AQ, barium sulfate solid. Okay, so we're going to do the same thing. We are going to balance it first. So to balance it, you simply need 2 there. And I think that is it again for this one. Yes. Okay, again, if you don't know how to balance it, you need to make sure you go back and look through that stuff. Okay, so step 1, done. Most missed step is the balancing piece. So you've got to make sure you go back and do that. Next step is to write the complete ionic equation. So to write the complete ionic equation, again, you split up your compounds into the ion. So for this one, we have 2 Cu. Do we know the charge of copper by looking at the periodic table? No. So this is where we have to go back and be able to find your charges. So we need to find the charge of copper, just like we did before. So how many coppers do we have? 2. X plus, how many sulfates do we have? 1. The charge of sulfate is -2. All equals 0. So then you get 2x minus 2 equals 0. 2x equals 2. So x equals 1. So that tells us copper has a charge of 1 plus. If you do not remember how to do this, you need to get extra help. Okay? So copper has a 1 plus charge, and it is aqueous. Plus, now we have our sulfate, SO4. There's only one of them. It has a 2 negative charge, AQ. Plus, now we do the same thing to the next compound, so we split it up. Barium, there's only one. Barium has a 2 plus charge, and it is aqueous. Plus, how many chlorines? 2, Cl, 1 negative, AQ. Produces, now we have the right side of the arrow, 2, Cu. Now a good thing about this is that whatever the charge of copper is on the left side, the charge of the copper is the same on the right. Your charges do not change as you go from the reactants to the products. So that means copper here still has a 1 plus charge, plus 2Cl, 1 negative AQ, plus, okay, we have our solid, the driving force behind the reaction, nothing happens to it. It stays the same. So that is the complete ionic equation. So now you have to be able to give me the net. So again, cross out things that appear on both sides. So we have copper, gone. Next, SO4, do you see it on both sides? Yes, but they don't look alike. This is your ion form that's in a compound, so you don't split it up. Ba, same thing. Cl goes away. So your net ionic would be SO4, 2 negative, AQ, plus Ba, 2 plus, AQ, produces Ba, SO4S. Okay. You now need to take a second and try this one on your own. When you are done, bring the video back up and check your answers. You now need to check your answers and make sure that you've gotten the complete ionic equation and the net ionic equation correct. Every little piece is part of a point. So you've got to make sure that you have your equation balanced and that you have all the symbols written correctly, all the charges are correct, and all the states are correct as well. Again, to double check yourself, look at that net ionic equation. These two ions should be what makes up the solid. Also, however many there are here should be here as well. So 1 iron and 3 hydroxides. 1 iron, 3 hydroxides.